Hello and welcome to lesson 5. Sorry, I'm going to break this lesson into a couple of sections. Lesson 5, part 1, part 2, part 3, maybe a part 4. But in lesson 5, what we're going to do is you're going to take the students deeper into the basics of electronics. Some of the basic blocks of electronic components that we will be using in Arduino. We are not necessarily teaching electronics entirely, but just based on what to be using for our Arduino projects. So that's where you take it from. Now, in this lesson, the students will have to do a lot of research and reading, okay, and understanding. So, as much as we are teaching him, we want the student to also know where to find information. So the first thing we're going to attack is resistors. Okay, so in this lesson, you would have to let a student do a Google search on resistors so that he can read, okay, what's a resistor, what are the types of resistors are out there, and things like that. The idea is that so that the knowledge the student gains is not limited to the knowledge the teacher has on resistors. Okay, but the main thing is that you're going to use resistors in series and parallel. That's kind of like the one of the main activities for this lesson. So let's do that. So you have to explain, okay, what does it mean for resistors? Not even just resistors, but for components connected in series and parallel, by using resistors for that. So when components are connected, when a resistors or load or anything is connected in series, means that the same current is flowing through it, but there are different voltages across each resistor depending on the resistance of the resistor, and then you can introduce V is equal to IR. So the main thing here is the student needs to know how to connect resistors in series and in parallel. So we take it, we're going to use a breadboard. That's with respect to not just connect, but with respect to what we are doing. So for this, we're going to use this breadboard. In fact, let's use both breadboards so that we see what is actually happening here. Now, the difference between this breadboard and this breadboard is, if you check, this one is only the main part of the board here. It doesn't include the power lines, you get me, or the power rails. So that's the only difference. So this one doesn't have power rails, this one has power rails. So this is smaller, this is bigger. Okay, so to do this, we're going to use about 5, let's just use 4 resistors. 1, 2, 3, 4. So over here, we are connecting the resistors in what? Parallel. Okay, and this is a good time to also do a diagram, a circuit diagram for the student. I think I mentioned the software we can use for circuit diagrams. I mentioned it in the previous, I think in lesson 3 also, you can refer. So we have this, and now let's connect in series. So we are doing 2, connecting in parallel and connecting in series. Show them and bring all the 4. And we're going to see what we're going to do over here. So we all know that, as mentioned, when connecting in series, one of the things that we all know is that usually our things in the house or appliances or light bulbs or stuff, loads are connected in parallel at home, so that when one thing goes off, or when one thing when one thing has a problem, the rest of them can stay intact. Because if let's say this is how your things were connected in the house, if let's say this is how your things were connected in the house, and something happened to this resistor and the circuit was broken, right? It would short circuit. But with this, if something happens to this resistor or to this load, let me call it the load instead. If something happens to this load and something happens to it and it's not working, and there's a short circuit here, these loads will still function correctly. So just to make everything work properly, let's add LEDs so that you can see what is happening. Because unless we want to like measure with maybe a voltmeter, we can't tell what is happening. You get me? But with I'm going to turn this, but with LEDs, at least we can tell. It sets us an indicator to see whether current is flowing or not. So let's do this. We're going to use let's use 3-volt battery. We'll use 9 volts. Let's use 9-volt battery. We'll add let's use 9-volt battery. There's a lot of power, but this is a 9-volt battery. Do the same thing here. So you can use a 3-volt battery or a 9-volt battery. Any of them will work. You just have to, if you're using a 9-volt battery, you need to increase the resistance. If you're using a 3-volt battery, you need to reduce the resistance, basically. So feel free in terms of which battery to use. Okay, so we are doing a series connection and a parallel connection. Also, we want to introduce to the student the fact that these the resistance of the resistor can be determined by the colors, the stripes, right? The colors of the stripes on it, and that you can easily find on Google, so that he will read and know how to calculate. So that's like literature. So should be able to do that. One thing we'll add exercises, something like exercises, things the student should be able to answer as well. It will be a documentation, which I'll add. Okay, so let's power this. So we'll start from. So let's do something. Since all the wires are connected vertically, since the holes are connected vertically, all I'm going to do is that I'm going to put one here, you see, and then I'll tap for each of them. So here, get it? So it is kind of like the power rail. I'm using it the way I would have used this power rail. So then this, and then this. Let me pick this power from here. Okay, do you see how I'm doing it? The way I'm connecting this is that these are two different lines, you get me? And this line started from the hole itself. So when I came, I made sure that this red was highlighted so that I know I'm getting that terminal itself and not one of the wires, you get me? Because once this positive comes here, it means this whole line has power in it, has some 9 current flowing through it because of the 9 volt. So now that I've done this, I need to earth everything. So in doing the earth, we can do it in a similar way. by bam, then I'm taking from the latest now. You guys can see this is tricky. Okay. Then the fourth, I'm going to just go here via a little. I could have made let me make it nice. I always tell my students to make their circuits look nice. Gotta do the same. So okay. So I'm doing this now. They are connected to this bar. So I can tap from here and then I put it here. So that's bam. What's the resistance of this resistor? 1 key. I think it's cool. So 1 key. If I should simulate, bam, all the lights come on, and even though the resistors are a lot, if you should check the voltage, they all have the same voltage across each other. You get me? Yeah. They all have the same voltage across each other, hence they are all bright, right? They are all bright. It looks like each of them has been hooked and none of them is sharing the power. Now what happens if I should take this away? I should take this resistor away, something is going to happen. Start simulation. Bam. What has happened is that this is no longer working, but the other three are working. So it's just like the load that you have in your house. When one light bulb has a problem, or when one part of the building or something has a problem, or when one component has a problem, it shouldn't affect everything in the house because they've been connected in parallel. I've put it back. Let's simulate it. Bam. Everything is back. Okay. So now that is that. Let's take it from here also. We have with a series connection. Connect to this. Bam. And bring this down, but make it look all professional. Okay. Then everything. This connected to this. This connected to this. Connected to this. Connected to this. Connected to this. So the whole series thing is going on. This should come here actually. Yeah. So I'm gonna just from the negative. Just a second. Maybe it doesn't work out. Just pause everything. I'm reloading the page. It's actually good this has happened. Once in a while, Tinker card messes up. Sometimes it might even refuse to load. You just want to refresh the page. See. So it's taking long. Let me pause this thing so that when it comes. Okay, so it's working now, and I've done the connection again. Is this really important? So a conventional tip is that anytime you're using positive terminal, the wire should be red, red and black. But this one, that's not the focus, so you can leave it on. Now let's simulate it. Bam. So we are simulating this, and we have current flowing through this. you have current flowing through this also, but because in a series connection the resistors add up. So if this is 1 key, it means that before the current gets here, it has phased 1, 2, 3, 4, 4,000, 4 key. Do you get it? So it's possible that the amount of current flowing through here is now so small it can't light up the LED. Hope you get me. Let me check it for my connections. Okay, no, this is wrong. Sorry, I made a mistake. This is wrong. This is totally wrong. This should be here. Sorry about that. That's terrible. Let me bring this down. Okay. Because I was wondering why the thing was not on at all. At least we should have some bright. Exactly. We should have some level of brightness. Because 4 key and 1 key, fine, there's a difference, but it's not that much if you look at 9-volt battery. Okay, so over here you realize that this is lit up, this is also lit up, but you can tell that the brightness of this is way more than the brightness of this, even though these LEDs are 4 and this one is. They're different. The reason being that the LEDs, the resistors, are connected in series, hence the accumulative load it's facing is 4K. This is different. The accumulative load it's facing is not 4K. So you can look at the formula. Total resistance of series is what is R1 plus R2 plus R3 plus R4 up to Rn, and being the number of resistors. Resistors in parallel is 1 over is it 1? I'll check the formula. I'm coming. Let's check the formula. I think there's yeah. Formula for adding resistors in it is it's R1 plus R2 plus R3 plus R4 over, so R1 plus R2 plus R3 plus R4 up to Rn over R1 plus, am I even right? I'm confused. Using blah 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 blah. So let's look at it. So that's why this stage has a lot of review. Adding 2 resistors, R2 times equal to R1. Yeah, R1, R2, R1 plus R2. Yep. So I would usually rather look at the formula like this. That is 1 over R2 times equals 1 over R1 plus 1 over R2, because then this is easier for me to remember. Yeah. So then you can look at it. R total is equal to R1 times R2 over R1 plus R2. So that's it. So the top is multiplying and the down is adding. Then you can look at it from this perspective. 1 over R total is equal to 1 over R1 plus 1 over R2 plus up to 1 over Rn. Hence, to find your R total, it's not the same as in series where you just add up your resistors. Okay, so hope we got that out of the way. So it's important that you and the student are doing some amount of literature, going online to see, to gain a good understanding of what he is doing. So that is it for resistors. Then we come to diode. Now diode is diode basically allows current to flow in one direction. So you don't really have to do much on this, but once the student should understand that once I turn this and the negative is here and the positive is here, you won't get current flowing, because current only flows in one direction. So when you change the direction of the diode, the current is not going to flow. So that's it for diode, hence we have the LED, which is the light emitting diode. So that's pretty much for the diode that we'll look at. Then you look at the button. Now in using the button is basically is almost like a switch, and with the button tool you need to do some literature. So it's called a push button. Push button. Did I just write circuit or something like that? So push button in circuit. Yeah. So push button in circuit. Okay, let me use this picture to explain. So basically, this is how the push button works. Let me see if I can get some good pictures here. Yep. So the push button is like this. These sides are connected. These sides are not connected. So these sides are connected. These sides are not connected. So when you do your connection, the sides that are connected act as a switch. So it's opened, and then when you press on the button, it closes. That's basically. Am I right? Come, let me get a better picture. I don't see this anymore. Come, let me pause this and get us a better picture so that I can. Okay, so I've gotten a good image here that makes it easy for me to explain and even understand. So over here you can see, so in the push button, two parts are already connected, right? And then two other parts now get connected when the button is pressed, and then disconnect when the button is released. That's basically it. So depending on the kind of connection you make, you can turn on or off a couple of things at the same time, probably two things at the same time, depending on how you're using it. Okay. Also, the state of the push button is off. So the push button is off, and then when you press it, its state is now on. This you get to understand better when we start using it in programming. Okay, so just like we did for, you come into Tinkercad with your push button. Let me just slide this away. So let's use so we're going to use a 3-volt current cell resistor, and let's use a push button. So based on how we saw it, this and this are connected, right? Based on how we saw it, this and this are connected, but this and this are not connected. So what we will have to do, if we want to use the push button to control this LED, we want to use the push button to control this LED, then we need to create a connection such that this connects to the resistor, and then remember this and this are not connected, so we can then, in fact, we can just bam. Right. And then should I turn this? No need. And then we give positive here. Remember, this and this, terminal 1A, terminal 1B, terminal 1A, terminal 1B are already connected. So if I shall make the connection here, the thing would already be on. I could have made what's happening? Oh, not this again. Just a second. Let me pause again. Tinkercad is okay. So for some reason, my Tinkercad platform keeps messing up. So these things happen. So I'm connecting this. Then so what's up? Just a sec. Okay, so we run the simulation, nothing happens. We click the button, you see, on. We run the simulation, nothing happens because they are not connected. But when we click the button, they turn on, right? Because then the button closes terminal 1B and terminal 2B and terminal 1A and terminal 2A. So it closes these parts of the circuit, and then the LED turns on. Voila. Okay, so the video is longer than I expected. I was supposed to add 2 more things, but because of doing the research and showing you how to get your student to do some literature as well, hence it's gotten long. Hence we've done only resistors, diode we didn't really do much, and then button. So we have switch, potentiometer, and photoresistor, which will be in part 1B. Means that the video is actually going to be more than 3 parts. I'm sure it will end up being more than 4 or 5. So thank you very much. All the best.